So let's get into some CAD stuff here. What I've got here is, all right, this is my CAD drawing for this part. Here I've got a drawing for the blank that I'll use. The bending die, this is what I'm making now, and then the co-located parts. You can see where the flange is here that'll bend over the die. This is just a 3D part, rendering of the part, so you can kind of look at it in 3 dimensions and see what it looks like on the drawing there. That's just kind of pretty stuff, and then I've got a data blank here, a data card that goes with it. Okay, so back to the task at hand here. Here's the bending die that we're going to make. We're going to cut it just the way that it looks on the mill. It's going to be pointing to the right. It's a right-handed die, and this is what I'm setting up for the hole diagrams. Remember I said one of them is always even numbered, so here the nose tooling hole is at 12 and x12 y2, and so when I cut the holes on the back side, of course I've got to flip it over, and so that's what you see here. This is going to be at 2 and 2, and it's going to give me an odd number for this. Now over here is where I backed up 1 inch for the fixturing hole, so what I need to go do is use my point incremental and drop in another point that is 1 inch to the east side of that, the right side. So line up there, drops the hole in there, and then now I'm going to use the same thing, and I'm going to go 10 inches back to the left to the west, and that'll give me my other fixturing hole. So let's swing over here and pop on that, and it gives me, well, it should have. Oh, I'm putting them in the wrong place. I gotta go -10. Alright, now I'll swing over here, do the same thing. Zone in here, pop one, and there's my other fixturing hole. Now you can see it there. So I'm going to finish up this CAD work, get the points, and then we'll go back and we'll just put those in the mill by hand rather than writing a program, and I'll show you that. Okay, so here's what I came up with. This is what our hole pattern is going to be for the die, and then I've taken and written those down. It's kind of simple because they're all on y = 2, and then we got 4 different spots on x, and then all I'm going to do is use the mill to locate these positions, and I'm just going to put in a center drill and just mark the holes, and then I'll take it over to the drill press and cut them out with the drill. I prefer using a drill, especially on this softer aluminum. I can't tell what the mill's doing, but you know, using the drill press I can tell if it's getting gummy in there, and with the mill it's just I've used it and I can use it, but I prefer just to do it in the drill press if I can, because it just gives me a little more tactile feel about what's going on when I'm drilling these holes, especially when they're small holes. Bigger holes are a lot easier to do with this soft aluminum in the mill. So anyway, let's get going with that. Okay, I got the mill powered up. I got my rotary phase converter running. It's a little bit more noisy in here, but I've got my mill set up so that when I don't need to use the spindle and I'm just tracing parts or doing programming on the control, I can run on single phase and just turn the 3-phase off. But for this, I've got to obviously have the 3-phase on. So there's the first tooling hole, and again, we're doing 2 and 2 for the first one. So what I got to do is go up here and set my x is equal to 2, and set my y. It's already actually equal to 2. And Z, I don't care what it is right now. I'm just going to manually bump this down and do a little drill action. I'm going to set my spindle speed set at 1,000. I got 42 inches a minute. It's a little fast. I'm going to bring it down to 10 inches a minute, and I'm going to set the override at about 4 inches a minute for starters. Then we'll just kick it on, and I'm going to use the -Z to bump it down and mark that hole. And I can go spindle back off while we're doing that. Next point is 3.5173. So I got to go in here and make x equal to 3.5173, and I can hit go, and the machine will move, run the feed rate up a little bit so it gets over there more quickly. Alright, feed rate's back down, turn the spindle back on, and we'll just bump it down by hand. And I'm just marking them so that I can drill them again. This time I'm leaving it on. I gotta go now, X, and I'm going to 12.5173, and I'll make it go, bring the feed rate up so it gets over there a little more quickly. Alright, I paused it to get over here. There's no reason for you guys to watch the mill move. And I'm going to go ahead and just do the rest of those holes and bring it back when we're done. Okay, there's the part with the holes marked. I've taken it and unclamped it from the mill. I turned the rotary phase converter back off so it's a little more quiet in here. Now I'm just going to go over to the drill press. I'm going to drill the tooling holes all the way through to the top of the part, or to the die, and then the fixturing holes I'm going to drill about 3/4 of an inch, and then I'm going to tap them with a 1024, and I'll bring you back when I got that done. Okay, here's the die piece. Holes are drilled, tooling holes drilled through, fixture holes are drilled 3/4 and tapped out. I deburred the holes. Now what I'm going to do is I'm going to flip this thing over, and I'm going to take the other die that I have machined, and this is you know, it's not really cheating, but it's taking advantage of the tools that I have here. I'm going to try to it's not wanting to go through there. I've got a couple of these 1/8 pins. I'm going to do this and then I'll bring you back. Okay, so as I was saying, I just used the old die, and all I'm really doing, you don't have to do this step, but I'm just putting a mark here that's a little bit bigger than what the die is going to turn out to be, so that I can cut it, and then it's also a witness line so that I can test my programs in the mill before I run them, just to make sure I'm not doing something silly and ruining another die. So, got that marked now. Pull these up, and there's the outline of the die we're going to cut. And the next step, I believe, is to take this to the bandsaw and cut out the profile on it, get it closer down to size, and then we'll mount it on the fixture plate. Here's a little quick tidbit of the sawing. It's a fairly slow process with the 1/8 material. Seems like it takes longer to cut 1 inch once than 2 1/2 inch pieces and laminate them together, but it is what it is, and I'll save you the boredom. Okay, I'm back. Here's our part cut out, our die cut out. Some of you may have been wondering why I canted that part on the piece that I had, and the answer is to cut down on the sawing. I basically had to saw about a 1 1/3 around this thing, a side and a third. that was about 40 minutes of sawing, the 1-inch stuff. And I got a pretty decent blade in my saw. It's a it's about an $80 bimetal variable tooth blade, and but it just takes a while to chew through that 1-inch material. So anyway, it's now ready to go. We can clean it up a bit. I'm gonna file off the rough edges on the bottom along the saw cut, and then we'll put it in the fixture plate. Okay, back at the mill. I've got the die upside down, and we're getting ready to put the put it on the fixture plate. These are my 40,000 spacers. They're sacrificial, really, and again, they're there just to provide space for the tool between the fixture plate and the bottom of the parts, so that I can run the tools down as close as I can get them. There's nothing special about these. I clean them off to make sure I don't get any so that the part lays flat. Flatness is kind of an issue. You want the die to be pretty flat, because when you're pressing your parts in the press, if you've got a warped die, then you're going to end up with a warped part, obviously. Alright, now I can't do it with one hand. I'm holding the camera here with one hand, but I'm going to take this fixture plate. It's right side up right now. I'm going to flip it upside down and put it on top of this, and put the two fixture bolts in, the two 1024 countersunk. They're sitting right there, and then I'll bring it back. Okay, we're back. We've got the die lined up on the top side of the fixture plate, and I'm putting the 1024 screws down in here. They might seem small, but they've got a pretty good clamping force, and with those two strips there, I get a little bit of purchase using just these little screws, and it seems to work okay. I haven't any problems. I've done some fairly big dies. If I get any bigger than the die that I'm doing right now, I might want to go to a 1/4 inch and or more of the 1024s. 1024s just work nice because they're easy to tap the bottom side of the dies, and they hold pretty good as long as I'm doing my machining correctly and I'm not messing up and crashing tools. It should be enough clamping force to hold that, because the cutting forces for this aluminum really aren't all that huge. So there we are. It's in the die. I'm going to clean off the bottom of the fixture plate, and I'm going to clean the bed of the mill real good. Again, I don't want any chunks laying in there and tipping this thing cattywampus, so that it's not on there flat. Flatness is the big reason for machining for flatness is the roundover bit. I found that the roundover bit's very, very susceptible to Z-height differences, and it will quickly leave a streak around the outside of your part. So I'll roll this back over here, and we're going to machine this pointed to the right. I've got 4 little T-bolts down in the bed there. I'm going to go ahead and hook this thing up, and then I'll bring you back. Okay, I've got the bolts in there lightly. Now I am over here, and if you remember, the tooling hole up by the nose, the tip of the nose rib here, is going to be the one that I set the mill to, and that's going to be set to y = 2 and x = 12, and then the profile is built around that. So now what I'm doing is just getting an alignment on this, and it's going to take me 2 hands to do this, but I'm giving you an idea of what I'm doing. I'm just slowly bringing this pin, it's actually the back end of a 1/8 inch drill bit, and I'm bringing it in there, and I'm going to line it up on that hole, and then when it slips down in there, I will slightly tighten these 2 1/4 inch countersunk screws, and then I'll go down to the other end and just drop the pin in there to make sure that it's right, and then I'll tighten up the screws on this end, and that should be in line. That should get it pretty well aligned for machining. So I'm going to do that, and then we'll come back. Okay, I've got the pin in there. I just aligned it, and I've snugged the bolts down. I'm dropping the table down a little bit, and now I'm gonna go up here and set that to X is 12, and Y is 2. That's got my mill centered up now in that hole. That's going to be the controlling hole, and the profile of this part is built around that hole. So all my software, all my CAM software, that's got to be the point that matters. And then this profile, if I have that set wrong, I'm going to end up with a tool in here or a tool out here, and it's not going to cut right. So that's the big deal. All right, now I'm going to run it down to the other end and just check that hole down there. Make sure that I'm lined up and Y is still 2 there. X doesn't matter because it is what it is, but I just got to have it aligned to the Y so that the part's not sitting in cattywampus that direction. Okay, I've got the other hole lined up. You can see it there. I did have to bump the die down a little bit, and what's happening is it's just slopping in the slots here. The bolts here are slopping in the slots to get it lined up. So I've tightened those down over there. Now I'm going to go make one more quick check and make sure my hole's still fairly aligned in Y up here. And there it is. I did have to bump it south just a little bit. It got misaligned, but I just bumped it a little bit and got it back lined up. So my Y is right. Now I'm going to torque these down pretty good and tight to hold the fixture in place while we're machining. There's 2 of them. This one's already fairly tight, and this one's tightened up. So I'm going to crank the knee down, bring that out of there, and we're in position. Time to go do some cam work and get our program ready to run. Okay, back at the computer. Here's the CAD drawing of our part. Remember I said we're at everything is on Y2 here, and X for the far point is at 12, and then the other tool hole is here. That doesn't really matter. What matters is I've got the mill set for this tooling hole at 2 and 12, so the profile will be built around that point. So all the G code that gets created will be based on the mill being set up at that point. Alright, I'm going to go ahead and I'm going to do a file save as. I'm going to save this as a little bit different name. Instead of just die, I'm going to make it the die profile and save that. And the reason I'm going to do that is because now for the CAM software, I got to get rid of all this extra stuff. So I want to get rid of got to get rid of all the dimensions. Delete. I'm going to get rid of this. The tool holes. They're gone. And I've got to extend this profile out 1 inch, and I'll do that off camera, and then I'll come back and bring it back. But the reason for that is when the tool drops in, I want it to drop in far enough off the end of the piece of aluminum, and then as it starts to move, it'll approach it. Instead of the tool, if I just do it right here, it'll try to drop down on top of the aluminum, and I'd rather it drop down here and then start moving this way and start cutting. So I'm going to go do that, and I'll be back. Okay, I've got that done, and now I'm going to come up here and save this. And as you can see, I extended the line out from that profile out past here, so it's 1 inch past where it was before. Okay, now I also have to save this. I got to do a file save as, same file name, but I got to save it as an AutoCAD file because I use that to import it into my CAM software. Now the CAM software, I use SheetCam, and it looks like this. Great program, absolutely easy to use for me. I've I've gotten used to it. It's great for 2 and even 2.5D cam work. Les has been awesome helping me set up post processors and the like. So I gotta go up now and find, this is a 189, and I gotta make a new file for it. I got a little bit of work to do. I'll save you the boredom and I'll come back. Okay, got some bookkeeping done. Now I'm back to opening, actually I'm importing an image, and what I'm going to import is 189 right dia profile, and say open. Comes up, there's some windows here to mess with, and there you see the profile. Something's wrong, it's pointing the wrong way. Stand by. Not sure what that was, but when I imported the second time it came up right. Might have just been I clicked on the wrong button, but anyway, you see the profile here. And now in sheet cam, while you go down, you just go down here to this little tool right here that says create a new contour operation. So we're going to do that, and the first operation I'm going to do is using a 1-inch roughing end mill. I want it to go the entire depth, so I'm going to drop it to the 1.02 like I mentioned earlier. Depth for pass is 125. That's just so it does it all in one. Finish allowance, this is where I'm going to leave a finish allowance of 0.062. That's going to effectively, the program, the CAM software will make the part that much larger, and it'll back the tool away from the actual profile that much, which will give me room for it'll take off the high spots around the outside of the die, and then I'll come back in and I'm gonna do the same thing with a 15 thousandths and just keep sneaking in on the profile with that roughing. Then let's see, 10 inches a minute is good, plunge is 5, 0 ramp, 800 RPM, that's all worked in the past, so it should be good. And then it'll build the profile, but now it's showing an inside cut. I don't know why, but because this is an open path, the way you get around that, I'm going to turn off the green so you can see it here. I select S for the start tool, and then if I come down here I can move this over. Yeah, why is it not doing it for me? There it is. And move the start path over here, and then you can see that when I turn this back on, now it's moved. It's doing a climb cut, so the tool's going to come up here, and it's going to start coming around here and do a climb cut around the nose and come back this way. So now I have to, I'm just going to save that job as die profile, and then I put the name RUFF062 for the allowance, and then I have to go up and post process it. So I come up here and click post processor, it automatically gives it the same name. I'm going to rename it anyway, and this part number is 53246, and it's the first operation I'm going to do, so I call it op 1. So 352461 is my first operation. That's the way I remember. It's just a part number for the airplane part numbers. Say okay, it did the post processing, and it gives you some data about that, and just say okay. Now I can minimize this, and then I got to go in here and find, I'm now in the right side. Actually, it probably put it back in the one I was doing earlier. I imagine it's in 92, right? Nope, it's not there. Where did it put it? I'll go find it and bring it back. Okay, I found the file, and I got it in the right folder now, so I'm going to pull it up for you just so you can see what it is. But it's just our die profile. This is a number that has to be on for the control on the knee mill. It likes that number, and there's kind of a percent number. These are just comments, and then of course this is just G-code, and that's the tool path that the profile is. I've got a little bit of handwork I got to do to this. I've just got to clean up a few things, and I'll go do that now and then bring you back.